SNR1 is at 100 kilohertz, and SNR2 will be what? 10 times, even much more. ठीक है, it will be exponentially high, improve. ठीक है, your signal to noise ratio S by N with respect to operating frequency, okay, increases, improves exponentially. Understand? Like this way you can do. Done? So that we have been already seen. So that is 1 by omega n square somewhere. Okay, that is something I can take because it's decimal scale now. So 10 by omega n square. If needed, you can take 10 raised to 2 upon omega n square, so and so. Right? Now you plot it. Now you replace the value of your zeta. And what was the value of zeta? You identified. That is your natural frequency. Let me write it again. Omega n was k by m. Zeta is k by
2k.
2k. Above numerator
beta
b. अच्छा, your friction, ठीक है ना? That is your friction b, or some of you also write it number small n, depending on your control system number. Both are same. This one is not frequency. Km. So K is your stiffness, M is mass, this is friction. Right? So these two you know. Now if zeta is equal to 0, what will happen? If zeta is equal to 0, what is the condition? If zeta is equal to 0, what kind of damping it is? Any damping? Undamped? Undamped, na? There is no damping. Why? Now look at this scale. What will happen? Your curve will move like this. This outer shell you see, in your reference node you can see. This one is actually zeta is equal to 0. Understand? This is the reason that why you are not getting any damping, because this will reach, these two curves will adjoin themselves at infinity. Understand? Now take some value. Let's say zeta is equal to 0.1. So if zeta is equal to 0 is moving in this way, so zeta is equal to 1 will move somewhere like this. Getting my point? Then zeta is equal to 1 means 0.1. 0.2, keep on increasing the value of zeta. Damping, what will happen? That means you are increasing the percentage of damping now. Understand? Getting my point? Higher the damping is, quicker the settling. Getting my point? So therefore, if zeta is equal to 1, ultimate value is 1. ठीक है ना? 0 is lower limit, 1 is higher limit. This is critical damping. ठीक है? So critically damping happened. So what happened? We have been already seeing that if this is my input, so system will settle within no time. The same, quick reaction time. So that means it is as good as able to attend to infinite rate of change within no time. ठीक है ना? Theoretically, practically now I cannot achieve. Okay? Even theoretically it is difficult to achieve. Otherwise, I have to satisfy a non-causal function. Okay? Now, to realize any function or any signal or any system practically, it has to be a causal system or causal function or a causal signal. Okay? Probably you have already studied this part in signal and system. If not, reject. Getting my point? Now you keep the increase the value of zeta. What will happen? This slope will move something like this. Okay? 0.3 will further. 0.4, 0.5. Understand? So this shoot up part, impulsive part will be sliced up. Getting my point? Because it is slicing down, so your system will settle relatively fast as compared to previous one. Getting my point? Okay? So now this is say 0.5. These are the real case studies. If this is 0, so this is something 0.5. So obviously then it will be 0.6. This one will be 0.7. Okay? This latter curve roughly you see, this one is zeta is equal to 1. Understand? Okay? Matchable? This one is there is the time, this one is on frequency. Okay? So that is the reason that why deliberately most of these systems, we try to have the value of damping ratio between 0.6 to 0.7. Most of, not all, highly desired application. Okay? Now it's slightly changed. Okay? Hydro are relatively much lower than nuclear turbines. In case of nuclear turbine, value will be roughly around 0.75. On case of hydro turbine, it will be roughly around 0.45, 0.5. Okay? Obviously, if it is a steam turbine, normally in the coal-fired power plant, it will be roughly around 0.6, 0.67, something like that. Okay? If it is a gas-fired, so relatively quicker as compared to coal, so around 0.67. Clear? So we purposely keep it here itself. Why? Because it also needs some time. Because now you are allowing the damping purposely. Why you are allowing? Because you want to deliberately achieve this under damped condition. Under damped condition, you want that your system should experience some damping. Why? Because ultimately I want that my desire is this system should ultimately settle down. Are you getting my point? Okay. If you are designing a vibration sensor, so it should respond you only if it is experiencing some vibration. Right? Now once vibration is what? That is also a kind of acoustic signal, I can say. Now once the vibration is, the origin is gone, so what should happen? The sensor also after some definite amount of time should stop feeling any vibration, or it should keep on feeling. Ajay, are you getting my point? It should also stop feeling, na? So it should, that means this input xi should be also tending to 0. If this input is tending to 0, then only this x naught will also tending to 0, na? Then your sensor will say that okay, now there is no vibration. Okay? Or even if it is well within the tolerance range. It is as good as no vibration. Getting my point? Okay? So, how can I say? Say for example, the best place would be somewhere, if sometime you will visit Kolkata, you can see those old age ambassador taxis. Very heavy service. Understand? So that time the philosophy was that at the initial age, 50 years, 60 years back, in the motorized industry, that if the body, okay, or the mechanics is heavier, it will be more stable. That's of course true. That is still valid. Okay? That device will not puncture if it will get to any accident as compared to these current age commercial vehicles we buy. And still today, if you will buy any very high-end vehicles, very high-end vehicles, they are still heavier. So that is one thing. Understand? But what I am trying to see, you just sit back in those vehicles. Those are actually manufactured roughly around 4 decades back. Okay, you will feel a lot of vibration. What you will not experience in nowadays car or jeep or whatever kind of device you see. Why? Because they developed by the time enough mechanics that if the device is getting some vibration in one direction, and if you are unable to settle down that vibration, so ultimately the subject which is sitting over that body will also feel the same vibration. Okay? But let's say if the vibration is coming in from positive x direction, and you are able to neutralize that vibration the same amount in negative x direction, what will happen? The total accumulative value will be nearly 0. Is it means that device is not feeling any vibration? No, there is a vibration, but the subject which is sitting over the body is not experiencing. That is exactly what we want. Understand? So there are also these vibration sensors also very vital now. Okay? So anyway, so from that perspective, remember as far as this device, what we have taken as a case study, one dimensional accelerometer or vibration sensor. These are primarily operating at 25 kilohertz. 25 kilohertz is a bandwidth, remember. It's not an operating frequency. Operating frequency is somewhere around hundreds of kilohertz. Okay? So write down these questions. These are already with you. Okay? So these problems I am expecting you to solve as a part of your assignment. What else? Anything wrong with it? Okay. Okay. Question number 1. Develop a control mechanism. Sir, what about you? Yes, good. Develop a control mechanism for the vibration control due to number 1, first part, seismic operation or seismic action you can write. Okay? Seismic action experienced by a skyscraper, very high rise buildings, है ना, 40 floor, 50 floor, 100 floor, है ना, we call skyscrapers, ठीक है, extremely high rise buildings, ठीक है. For what? For this unit, ठीक है, for this ms square plus bs plus k into x naught s is equal to k xi. So this is already given. Remember, now this part is given k, not m. So there is a slight modification if you see the inputs. What was the original equation? This was the original equation. No? Okay. Now the problem has been a little bit modified. That the input side is k. So what was the actually transfer function? K upon ms square plus bs plus. Get my point? So for this you are going to develop. Okay? Question number 2. It is actually more or less same. Only it is twisted for your reference. Demonstrate a second order process control model. Demonstrate a second order process control model of this mathematical model is given again. Now this time it is given b of this. Okay? So in one case the input is related to mass. Okay? There is some input is given to mass. But do you understand it or not? In that mass spring damper system, you have 3 things. One is mass, one is damper, one is stiffness, spring. Spring is a stiffness. Okay? So one time input is given to the mass, one time input is given to stiffness, one time input is given to friction. Get my point? So there will be a slight change in your equations, remember. So now for this modified equation, okay, you need to draw a neat schematic diagram. You have 2 options. Either you draw a schematic diagram like we developed a schematic diagram for this case, or P&I diagram. P&I means P&I. What is it? Proportional integral. Any other option? Proportional integral. डेरिवेटिव आ गया तो कौन करेगा? क्या करोगे भाई? P stands for piping. I stands for instrumentation. D stands for diagram. Piping and instrumentation diagram. ठीक है? Likewise, in electrical power stream, we use a term SLD. है ना? S for stands for single, L stands for line, D stands for diagram. So, for wherever lot of conductors are involved. Okay? Okay? The series parallel combination of conductors and the ancillaries power devices. It has a transformer, it has a feeder, bus bar, XYZ. So represent that architecture, we draw SLD, single line diagram. Okay? So whenever you need to develop this C&I of a system, okay, a complete automated or semi-automated system, automated platform for a system, okay, maybe semi-automation, maybe fully automation, you draw P and ID. So depending on your understanding, I will talk to you. If you are unable with the P and ID, you simply go for this schematic diagram. No problem. Okay? Diagram and develop a mathematical model. So these are the two additional questions for you. Clear? Please solve these questions for exercise purpose as a part of the assignment. Okay? Assume that one part we have already covered. This is okay. Now, slowly I will cover this instrumentation amplifier. Any doubt in instrumentation amplifier? Okay? How do we develop? Ali, how do we develop? One input, V1, is it? So what kind of circuit these are? What is it? What is the gain of this? Gain. What is the voltage input here? What about voltage I can measure here? V1. Apply the virtual short condition. ठीक है ना? Same potential is resistance. V1 will appear here. है ना? What is the amount of resistance? 1. ठीक है ना? This is your unity of a circuit. This is the voltage, so it's voltage also. ठीक है ना? Or in a simpler word, you can write down unity proportion. Take these two and one differential amplifier. Okay? Right. I think already I have provided you those notes. If you want to take the help of this, if you want you draw on your own, it is up to you. Absolutely no reservations. Go. Any value you can assume. For example, A is A1, A2, or G1, G2, G3, whatever you want. Some finite value. Take any symbolic representation. Follow Mataji. What kind of amplifier it is? Yeah? Operational. Operational amplifier. The operational. Which kind of operational amplifier it is? No idea. Why you are not focusing here? Are they same? A1, A3? A1, A2? A1, A2 are the same or not? Eh? No. Consider two different gain because you cannot ideally make two transistors exactly same. Similarly, you cannot make two amplifiers exactly same with precision level 0.00. There will be some difference, but if it is calculative difference, it is fine. These two are the buffer amplifier. What is the value of feedback? 1. So it is as good as I can say that it is unity buffer. Now it can be a current buffer, it can be a voltage buffer. No problem. This time my input is voltage, so it's a voltage buffer. Okay? If feedback is 1, then it is unity buffer. If feedback is more than 1, so multiply times of that value. Okay? Now if I am taking R1 here, so I am considering R1 here purposely. Okay? So that this two architecture will able to commonality, will provide you some commonality. Okay? Nothing wrong if you will prefer some other resistance, no problem. Okay? It will slightly enhance your calculation, that's all. Now this one is different because it is bridging between two. So that will be definitely different. So these two resistances you can take same. So if you can take same, if I will have flexibility, why will not prefer same resistance? Because it will ease down my job. The same number of pieces I can order 2 times rather than ordering 2 different pieces one. Okay? That will increase my complexity. Okay? So this one is same, this one is same. Now you think about. Say for example, here the input voltage is V1. So isn't it the same here? V1. What is the voltage here? V1. Possible, no? What about here? Say it is V2. So if it is V2, then it will be V2 here also. Sure? So obviously there is a potential gap. Some current will flow. Let's say it is I. As for the architecture I shared. Okay? You take any XYZ value, no problem. Okay? So obviously the amount of current is flowing in this entire channel is I. This one to this one. Okay? Now what is the value of I? I is not my motto, but ultimately let me just write it for my reference. This is the value of I. Yes? Now, this voltage and this voltage, will it be same? Same? No? Whatever is here, is it same here? Same here, no? Now whatever is here, is it same here? Possible? But if there would be some resistance here, then drop is there, no? So that means this voltage drop will be different than this. Now symbolically, for my easiness, because here I have written V1, so I am writing V0. Something related. You write V3, no problem. Okay? So the same fashion at this point, I am writing V02 because it is referring to V2. Something different than this. Okay? So whatever the amount of drop that you can calculate from here. If this resistance value is very high, there will be a calculative drop. If it is very low, there will be hardly any drop. Few. Okay? Some value. Okay? So another thing what I will do that I will calculate this draw. That is also not my objective. V naught 1 minus V naught 2. This minus this. Now R1 plus R2 plus R1. Is it not? So it is twice R1 plus R2. Okay? Upon R2 into V1 minus V2. Okay? Any problem? V1 is already known to us, that is input supply. V2 is also known to us, input supply. These are the discrete elements, R1, R2, already known to you. So ultimately it will bring some constant. Okay? This will give you difference of voltage, delta V, right? Now what is my motor? To get this the output, na? Yes? Yes or no? What are your statement? Let us put some resistance here because I cannot maintain the unity resistance somewhere. Okay? So for my purpose here, I am now touching 2 because it is R1, R2, so if you take it is R3, this value is R4, this one. Okay? R5, R6, anything else? Okay? This one. Understand? Otherwise, what happens? Same voltage will transfer. That is something I don't want. Right? So this part is actually differential amplifier. So you need 2 unity buffer circuit and 1 differential amplifier. Okay? So now this differential amplifier will give you output of V0 is equal to how much? R5 by R3, negative of, what was that? V1 minus V0 1 minus V0 2. Take. Is it not? Okay? Or I can write it in this way. Don't write it. V0 2 minus V0 1. This is up to you. Okay? Whatever is that you substitute, this value is already known to you. Substitute here. Okay? Now R5, R3 are also discrete values. That is also known to you. So R5 by R3 will give you some ratio, some finite ratio. Okay? Just twice R1 plus R2 upon R2 will again give you some finite ratio. Product of the two finite values is again finite. Can I treat it as a constant? So ultimately what output I got? V0 is proportional to delta V, where this delta V is equal to V0 1 minus V0. Is it okay? Got it or not? What was your objective there? What was the output? Absolute acceleration was converted to relative displacement plus minus delta x. Now plus minus delta x will be converged to delta V or not? Okay? So for direction either I can take plus minus. Either it is increasing or decreasing. Doesn't matter. Now, okay? Now for this delta V, if delta V input is already known to you, now depending on the value of this A1, A2, A3, ultimately you are getting these products or not here. So if you will simplify this model, so this V output, I can write over here that this V output is proportional to A1 into A2 into A3. Now what are these? Gain of the amplifiers. If let's say A1 is 10, A2 is 10, A3 is 100, what I will get? 10 raised to 5 times of the input value. What is my input? Delta V multiplied by 10 raised to 5. Get it? Get it? If it is in earlier in millivolt range, now it will reach to tens of volts. Okay? Good enough signal. Good enough signal to do my rest digital actions. Now you can convert into digital signal. Okay? If needed, I can modulate it and transmit it for hundreds of thousands of kilometers. But because it is my industry application, my end user is here itself within the range of 2 to 5 kilometers. So should I to go for such a cumbersome modulation and demodulation? Response is no, because this action you are doing for one signal, remember, and you are parallelly observing in an industry. Your controller is monitoring probably tens of thousands of signal at the same time, and your controller is also fitted necessary algorithm to process and take some kind of control action, okay, simultaneously to tens of the output signals. So for each and everything, if you will do this modulation and demodulation, it will be a senseless job. Okay. Number two, modulation, proper modulation technique you did only if you are interested to propagate the data for very long distance. So for to me, longer distance means you are wanted to travel for 50, 100, 1000 kilometers, okay, 2000 kilometers, 5000 kilometers, so and so. Okay. A plant of very complex plant may be around the periphery of size of some tens of to hundreds of kilometers range. Okay. Now it will have some certain number of digital controllers. So one controller is primarily dealing with some 1 square kilometer area, maybe 0.5 square kilometer area, something like that. Okay. So with that, I can do necessary job so that I don't require these modulation techniques. This is also very old age guy, isn't it? Getting my point? Okay. Now, so for that purpose, if you remember, I share you some additional data. The last part, okay? This one. All of you have? You must have. Huh? Already I shared. Let us take some actions. Huh? So what we got? Delta V, na? What we have now? Delta V. We have delta V plus minus A1, A2, A3. This is my output I got, na? Okay? Now how can I process these signals? So for purposely, I am taking a reference. Let's say the initial voltage of this signal is, now this signal has some amplitude, it is operating at some frequency, it will have a some duty cycle, yes or no? Or it is operating at certain frequency. Okay, anything new? Let's say I am defining that the original amplitude without any modulation, that means without any processing, that value is E0. Okay? You can take a reference of 2 volt, 1 volt, any finite value. Now this part is representing phase, this part, phi. If there is a no phase deviation, then it is 0. Okay? Now this part is active part, there is some inactive part. For your reference, let us I am assuming, I do not know, maybe if your duty cycle is 50%, then it will be exactly half. 50% on period, 50% off period. But if duty cycle is say 1/4, then this one is 25%, there is a rest 75%, something. Whatever you something assume. Now this is your time period T. Okay? Now if T is known, do I know my frequency? Yes? 1/T. Okay? So how many information we have now? There is a pulse width. Let's say that pulse width is A. Some value. Okay? Right now, depending on your duty cycle, if it is 50%, so it is exactly half, or it is a some value. Okay? If duty cycle will increase, then this pulse width will also increase. Active duration will increase. If duty cycle is decreasing, then this active duration will also decrease. Inactive duration will increase. Okay? You can take any value. Duty cycle 0.25, 0.5, 0.75, whatever. Okay? Take it what you can process. Don't take 0.63 because it looks very cool. ठीक है ना? कूल को जनरेट करते करते तुम्हारा सिस्टम हॉट हो जाएगा. तो ऐसा काम मत करना इंजीनियरिंग, ठीक है ना. प्रोवाइड सम रिलायबल एंड इजी टू अप्लाई सॉल्यूशन. One should be robust and one should be simple to apply. So I can generate easily 1 by 2. I can easily generate 1 by 2. ठीक है ना. So you will say that what is the problem, sir? You generate 1 by 3. No problem. Generate 1 by 3. You will get some fractional value 0.333. Then ignore rest of the values. Then again you have to put a counter of it. That ignore after 2 decimal point. Understand? If possible, you are there. So what are the components there? Amplitude, width, phase, time period, frequency. ठीक है? These are the maximum 5 components here. ठीक है? Your communication system is over or right now you are studying? Communication 1. You are studying. Modulation 2. Over. Over now. Very good. So how many components I need generally? Change in amplitude, ठीक है, that is your genuine nature, amplitude modulation class. Change in phase, change in frequency. These are the maximum thing you take. What I have taken here are input pulse. ठीक है, you can take any waveform, no problem. Now let's say you assume that it has been allowed to modulate. That means there is a some change. I won't say modulation because actual modulation has to satisfy certain criteria. In a way that now this amplitude is modified to E in place of E naught. E naught is an ambient value without doing anything. Okay? You switch on, you will get this value. Now E is a some other value. Okay? If at all I am interested to vary this amplitude to accommodate the input signal, input data, which is sensed by my sensor and processed by the desired measurement system, and then it is sending to the controller. Understand my point? Then it is transferring to the controller. Now controller is maybe 500 meter away, maybe 2 kilometer away from that device, that field device. Okay? Now you want to propagate this data from this point to 2 kilometer away, maybe to your house. Okay? Is it very far distance? No. Do I need modulation? So if I don't require modulation, I don't require complementary demodulation there also. Okay? So if I don't require these cumbersome devices, can I cut down my cost? If more number of devices I do not allow to get involved, am I not reducing the chances of failure of the system also? More the device will participate, higher the probability of failure is. Understand? Okay? So this E is modified. How is it modified? E is the total output which comes from the original input E naught plus some value. ठीक है? Let's say your input तो क्या लेते हो तुम? Modulating signal, message. What do you take? MT. Some people write CT or something. MT. Okay. M for message. So this is MT. Some proportionality constant. ठीक है? Because it is change in amplitude, so purposely I am writing KA. Purpose, है ना? Just to satisfy my requirement. A stands for amplitude. Okay? Now what is it? Some proportionality constant or not? Or can I say that this is the sensitivity factor? Okay? This is the amplitude sensitivity factor that allows to modulate this ambient signal E naught to reach the final value E. Yes? Now this E can be 20% upgradation of this E naught, 10%, 50%, I don't know. Okay? If the vibration is more, this E naught will increase further. If vibration is reducing, this E naught will also reduce. If vibration kills, this E naught will ultimately reach to 0 because this factor will become 0. Understand? So this is the ratio of this by this. So ultimately it is the ratio of certain volts upon volt. So what will happen? It will become dimensionless. Remember, right? Not in every case. In this case, it will become dimensionless. Okay? Input is voltage, output is also voltage. So volt by volt. Okay? So this will allow you to move your pulse in change in amplitude. Why? Because of the change in input signal, this empty. And what is this empty? This empty is this. Getting my point? Okay? Now you got the point that you are allowed to change the input signal in terms of amplitude. So if there is some unwanted signal, that is also changing with respect to amplitude. Both are operating at same frequency. Now how do you identify? Difficult, na? Difficult, na? But if I can add one more device in your circuit, phase shift amplitude detector, where this delta V ultimately you change to delta theta or phi, whatever you write. In this case I have written phi. Yeah? So changing phi. Now my data is changing with respect to phi. Unwanted signal is still changing with respect to amplitude. Can I identify? Easily? No. No. In your class of your same batch, she decided that okay, let me test sir's ability. Okay? So maybe her classmate is one of civil engineering student. She will bring her deliberately. बोले आज जाकर तो ask 2 questions to myself. Okay? I am asking you for example. है ना? ठीक है? No discrimination. I can take your reference also. ठीक? Fine. So, will I able to identify? नहीं? Yes. Probability is that may or may not, but it will not take much longer time. If you are going to repeat the same exercise again and again, someday you will be definitely. Likewise, for your previous senior batch, I have done once. There were 2 guys, they were kept on sitting in the last bench. Okay, fine, it's a 50 plus student batch, it happened. On that particular day, as usual, my standard practice, because my most lovable students are the backbenchers, I usually ask maximum question to those. I asked to those 2 students. Then they stand still and then they will start shouting. Well, ask to gaya. Later on they come to my cabin. Sir, sorry. It's my pleasure. If other branch student really wanted to attend my lecture, it shows my popularity. Why should I say negative? Isn't it? That means I am an on demand. Okay, please come and attend my lecture. No problem. The only thing is that intimately that if you want to attend, I will never say no. Okay. So now you see what happened. That is what I am saying. Your data is changing with respect to phase. Some other data is changing with respect to amplitude. Can you distinguish easily or not? Is this easy or the case 2? Your data is also changing with respect to amplitude. Unwanted data is also changing with respect to amplitude. Is this a good condition to distinguish, or the 2 different data are changing with respect to 2 different parameters? That is easy to distinguish. Which one easily trackable or identified? Two different, because one is operating with respect to phase, another is operating with respect to amplitude. I know that when I transmit this data to controller, it was with respect to change in phase, not change in amplitude. Understand? And we are following the same protocol. Remember, just take an example. Any time you confuse, just simply take an example of your any connecting device through your hard drives or through your laptop. You connect your pen drive. Is it ask you that what I need to do? It simply opens. Pop up, na? Why? Why? Because that connecting pins, it has some transmission protocol, communication protocol. Your laptop point is also has the same protocol. That's why they can exchange their language without any further input. Both speaks the same language. Okay? So you don't require to even dictate what next you need to do. But if both will speak different language, then tomorrow I will come and I will start delivering lecture in pure Telugu. Perfect Telugu. What will happen? 90% feedback will be gone. I don't know what he is saying actually. What is the problem? Isn't there is knowledge not there? No. I cannot appreciate that problem. ठीक है? So it's easy to understand, remember. So in this case you are playing with amplitude. Now what is happening when you allow to do that? You have already studied, so I will not kill your much time. So remember, when you are doing this, you have taken certain assumptions. Nothing is free. You have modulated this message. This, remember, again not perfect modulation, but still we called it PAM because you are changing your amplitude of pulse, okay, with respect to amplitude. So it is your pulse amplitude modulation. That's why you say. Okay? Understand now? Your analog modulation is a perfect modulation. Your digital modulation is also perfect modulation. Pulse family is not a modulation. It's a quasi-modulated system. Okay? It hasn't satisfied all the properties. Can you propagate this data for hundreds of kilometers? Any pulse? Can you propagate this data for hundreds of kilometers? Answer is no. Even not PFM. Understand? This data you can propagate 2 km, 5 km, worst case 10 km, limited range. Okay? When you modulated this one, how many features it has? 5. So I need to take care of the rest or not? Or I will leave it as it is. I allow to change this one at the cost phi is equal to 0, t is equal to t naught. Earlier it was t naught, now it is t. Remember that? Okay? Or similarly here you can assume a naught. Or the ambient values, modify. If there is no change, there is some ambient value E naught, A naught, E naught, F naught, phi is 0. I cannot write phi naught. If there is a no phase, that means phase is 0. Okay? Now, when you have done this, you have taken an assumption that the rest value phi is equal to 0, phi naught is equal to, okay? This what you call follow. Even if you do not want to take 0, you take it phi is equal to phi naught. That means there is no change. T is equal to T naught. Again no change. F is equal to F naught. What else? Width A is equal to A naught. Assume this. Then you allow only one parameter to vary. And in this case, if it is amplitude, then it is PAM. Understand? If it is a frequency, then, for example, if it is a frequency, then F is equal to F naught plus KF MT. Yeah, possible? So I am allowing to change F naught to F at the cost keeping E naught 0, or I cannot make 0 because then amplitude will become 0. So rather I am saying that E is equal to E naught. Also A is equal to A naught. Also T is equal to T naught. Therefore F is equal to F naught. Hello? No, you are changing F. Remember this, huh? So whenever you are going to change with respect to frequency or with respect to time, then you cannot take both assumptions at the same time. Okay? E may be equal to T naught, but F should not be equal to F. So then you will get additional mathematics. Okay? Additional engineering possible, but you cannot take it straightforward. Likewise, in the previous case I have taken. Okay? So now it is your PFM, pulse frequency modulation. Okay? I am keeping this one constant, F constant, Y constant, but allow to change the width. So that is pulse width modulation. Or can I say pulse position modulation? Both are same, right? Okay? Understand? Okay? Now you want to change this phi. You will keep this one constant, E and F both constant, and allow to change phi is equal to phi naught plus K naught MT. Now, that way you can define its sensitivity factor. some case dimension, some case dimensionless, but you can achieve this. Okay. If you will do so, time is over. Now I am extending today's class with 5-minute break.
Sir, जो केस रे frequency टा change होची, तो time period भी तो change होगा था. Time period same रहले तो frequency भी same रहले.
That's why I said that you have to apply some additional engineering. ठीक है? With phi, no problem. You are assuming t is equal to t naught, so therefore f will become f naught. ठीक है? With amplitude, no problem. Good question. है ना? With phi, with a, that means width, no problem. But pulse time modulation, something we don't do because it's not advisable. Because at all, if I am interested to do modulation, I will always jump to the frequency plane first of all. ठीक है? It is always desirable to apply because of its distinguished advantages. Because you want to calculate bandwidth, कहाँ पर calculate करो? On the frequency plane. You want to calculate the gain bandwidth product, again you want frequency response. You want a Q factor multiplied by bandwidth, what you require? Frequency plane. So either you apply the time plane or frequency plane. ठीक है? Modifying the time plane doesn't make any sense. Mathematically okay, practically doesn't have any application. If you are modifying this, then it is called pulse time modulation. But if at all I need to do pulse time, why not be able to? ठीक है? So remember, in these all cases, the worst case is PAF, the best case is PFF, and rest will lie in between. So say for example, you want to go for pulse width modulation or pulse position modulation, that will lie in between. ठीक है? Why? Will come to. Okay? Okay, you take some break. 2 minutes. 2 minutes to 2 minutes, huh? Then I will start. And if you are fresh, be seated here.